Hi, my name is Deborah Baines. I work at the ESASky Science Data Centre in Madrid, and I'm the product owner of ESASky. And I'm going to introduce you now to the ESASky tool and to pyESASky, which is the Jupyter widget for ESASky. This presentation is on behalf of the whole ESASky team, in particular Bruno Merin, Fabrizio Giordano, Elena Racero, Henrik Norman, Matthias Wangblad, and Marcos Lopez Caniego. One of the reasons we developed ESASky is because we were being asked by the users of our archives to create a multi-mission and multi-wavelength interface to our archival data. Now, this image that you see here is a word cloud made up of all the feedback that we received regarding the type of application needed. And as you can see, it's the data that is of most importance to our archive users. So we developed ESASky, which is an interface that lies on top of all the ESA astronomy archives and archives from other partner space agencies and large data centres. The tool doesn't replace the archives, but instead provides a different type of access to the data via an all-sky exploration interface that is multi-wavelength and project agnostic. The first public version of ESASky was released in May 2016, and our latest release was about 3 weeks ago, where we released ESASky in the Chinese language. So the tool is now available in English, Spanish, and in Mandarin. We know that a large percentage of the astronomical community are now using Python and AstroPy, and we also see a lot of queries being made to our archives via their AstroQuery modules. So we decided to create an ESASky Jupyter widget, which we've called pyESASky. And with this widget, you can upload your own data. Currently, these are tables, footprints, and HIPs, hierarchical progressive surveys, which is what you see in the background of ESASky, which I'll show you now in the demo. And you can also download any data found within ESASky. Plus, you can interact with the ESASky functionalities, such as the search, the background HIPs, the James Webb Planning Tool, the field of view, the grid, etc. So now I want to show you how ESASky works in a demo, so let me switch to my browser. And here we have ESASky. When you first open ESASky, you see this welcome box. We have two modes, Science and Explorer. I'm going to show you the Science mode today, which provides you with all the scientific functionalities available in the tool. So ESASky is an exploration style interface, as I said, and the entire sky here is available for you to search and explore, so you can zoom in and zoom out and pan around. Over here we have the search box, where you can search for any astronomical target, any solar system object, and you can also search by author or bib code and see the associated sources for a given author or paper. Now I'm going to go to the Horsehead Nebula. So here we're looking at sky, background sky in the optical with DSS, and you can change these background skies if you click on this first button here, and you can select via wavelength many different HIPs. So these are hierarchical progressive surveys that we're showing in the background. So let me open up, for example, in the X-ray we have background HIPs from XMM Newton. In the optical we've got the DSS2, we've got many others. I'll also open up the near infrared, the mid infrared from All Wise. Let's open up another one that's from Spitzer, and let's open the far infrared from Herschel Pax. And you see that we have this slider here along the bottom, so you can start actually play through all of these skies. Let's pause this, and you can also take a hold of the slider and pan through yourselves. So if I go back to optical. Now I want to show you how to find and download data. So these buttons over here with the numbers are showing us how many imaging observations are available in this region of the sky, this rectangular region. It also shows us how many catalogue sources are available and how many spectra are available. So these three buttons, we can access data, and also this fourth button here, which I'll show you in a moment. So let's first click on images. Here we see a tree map with the missions that have available data in the field of view of the screen. You can filter the missions by wavelength using this slider at the bottom. For example, if you're only interested in high energy, you could move this button along here, or perhaps you just want to see infrared to radio, then you can slide along here. If you want to find out any more information, then we've got these little help buttons with a question mark all over. So you can click on this, it gives you information, and it sends you to a link for the full documentation. And clicking on any mission will bring up the data. So let's click on Hubble in the optical, and we immediately see the footprints appearing in the sky and also the metadata down here in the data panel. And you can interact with the sky, so you can click on the footprint and the corresponding row highlights, or vice versa. You click in the table and the corresponding footprint will highlight. You can also filter any column. So let's take, for example, the instrument, and I could just look for ACS, and then immediately we see the results shown here. We have postcard previews that load up the postcard directly from the European Hubble Archive. And if you click on the observation ID, you open up the archive directly on this observation. And this little icon centers you in the observation, so you can find where you are. So to download the data, either select one, a few, or all of the data, and then go to this download button here and click on data products, and you download the data straight away. So this is the same for all other missions. So if we load up XMM, it's exactly the same. We can see the postcard straight from the archive. We have direct links to the archive, so it will load up this observation. And you can download your observations as well. So download these two data products just with a few clicks of the button. The same for Chandra, and Chandra takes you straight to the Chandra archive in Harvard. So it's very easy to download by selecting the data you want and clicking on the download button. So let me close all of these, and I'm going to show you now the catalogues. So here we have the button for the catalogues, and you find a very similar tree map for all catalogues available. This can also be filtered by wavelength. Over here we have an interesting cluster by the look of things. So let's load up the Gaia DR2 catalogue. And since this is an astrometric catalogue, we are seeing the proper motions here. The proper motions are indicated by the dotted lines. If you zoom in a lot on a source, then you'll see that the dotted line will turn into a solid line, and that's the true proper motion. Here we are. So let's zoom out again. You saw as I was clicking that this option of going to other surfaces becomes available. You can also get that if you right click. So if you click on a source, you'll get that, and if you right click, you'll get that. So let's go to this object, for example, and see what it is in Simbad. So this looks to be like this young stellar object, HD 37525. And we have the parallaxes and the proper motions. They're all from the Gaia DR2 catalogue. So if I go back, we can actually start filtering what we've loaded, and we can filter on the parallax and proper motions. So let me filter parallax between 0 and 3, or between 1 and 3. The proper motion between 0 and 2 in RA, and the proper motion in DEC between -2 and 0. And now you can see all the sources with these proper motions and parallaxes within these ranges, but we're still seeing the sources that don't have any parallax or proper motions within DR2. And if you want to download what you've been filtering, and of course if you want to download any of the tables, just select all and click on the download button, and you can either choose a CSV or a VO table. So we can find out more about this star as well by selecting the publications icon. So this is this button here. When I press this, all sources with an associated publication are shown. So I can then go to this star and we see that there are 63 publications. If we click on it, or if we select here, then we'll load up all of these publications. Now this is accessing the service provided by CDS, who have linked all publications to sources. You can again filter any column, so we could search, for example, for cluster. And here we can find out a bit more about this cluster. We can, if you click on any of the bib codes, then you'll open up the paper directly in ADS. And this little parchment button allows you to open up all of the sources in the publication. And you can start clicking through them. And they're all highlighted by a green square. So let's go back to the region that we were in, and you can now see all of these sources. If you want to distinguish between the sources that you've loaded and the Gaia catalogue, we can, for example, change the colour of the footprints or of the sources. So here we go. Here we can see the Gaia sources now as well. And linking all of these services enables faster data discovery, which we hope your science can benefit from. Let me close everything again, and let me close the publications and these sources. And the third button to find data is for spectra, and it's very similar, almost identical to downloading and finding and downloading imaging. So let's, for example, we have access to LAMOST from the Chinese Academy of Sciences. And you can see a preview of the spectra. And this is coming straight from the archive in Beijing. And if you click on here, we go straight to the archive as well. So we can load up all available spectra within the region. And you can download it exactly as we've been downloading with the images and the catalogues. So you click on this button here. So we also have a fourth button to access data. It's this one here. And this allows you to explore data from other external data centres. The data hasn't been curated by us, but we're accessing these data centres. We're using the Table Access Protocol, which is one of the virtual observatory standards that many astronomical data centres are using as one of the means to expose their data to the public. And currently this is accessing data from ESA, CADC in Canada and MAST in the US. So if I click on ESA, you can see here all the different data types that you can search for, and this includes ground-based and space-based data, obviously. So we have spectra, images, visibility and measurements. So there are also cube data and time series available. So if I go to images, we can load up the ESO VLT images in this region. And this is still interactive, so we can select footprints on the sky and interact with the data panel. And if you want to download the data, you click on this access URL and you select the first one, which is the Science Ready Fits. Click on this and you begin to download the data directly from ESO. And then if I go to DS9, we can see that we've loaded this data up from ESO. And we can do exactly the same for the other data centres. So let's click back. And in MAST, let's go on the cubes and select Swift. And for CADC, for example, let's take a look at Gemini spectra. So the Swift are already loaded. So we go to the access URL again to download the data, and it downloads directly for this mission. And for Gemini, we can center on the observations as well, and we download from the first link in the top. And in the near future, we are probably going to put all of this into fewer buttons to make it even more streamlined for you to find data. So everything will be a lot easier to find and a lot easier to download. So please do keep checking the latest versions of ESASky. Now let's reload and show you a couple more features. So via this button here, you can upload your own list of targets. And for information on the format, just click the help button and you can go to the documentation. So let's upload a target list here. You see that it's just simply a list that can be resolved by Simbad or coordinates. And you can also add a description here. So if I open this, then if you've added the description in the file, it pops up here. And we also have a lot of other target lists, example target lists for you to take a look at. This button here opens up the observations planning tool for James Webb. So if you click on the plus button and you're given 5 instruments of James Webb, so select one and then you can select any of the apertures, and you can also click on all of instruments to see the full focal plane. You can change the RA and deck, and you can rotate, and you can do this manually here. And once you're happy with all of this, you can copy the coordinates and data, and then this can be used in the James Webb Astronomers Planning tool. And this tool is for a quick look on how you'd like to do your proposals before moving on to the APT. Now, if you want to see the full sky coverage of all missions, zoom out and start loading up the global sky coverage for all of the missions. So let's do, for example, Hubble, Herschel. Here we see the galactic plane, ALMA, XMM, Chandra. You see this is very, very fast and easy to do. And you can do the same for the spectra as well. And we can see regions that have been highly observed, like the galactic plane or the ecliptic plane, and we see other regions that have been less observed. And we're looking here essentially at the whole history of data taken by the astronomy space missions. So finally in ESASky, I want to show you the solar system objects feature. So I've reloaded. In the search box, you can search for over 750,000 solar system objects, currently for 3 missions, Hubble, Herschel and XMM, Newton. And the ESASky team have created a pipeline that calculates the orbit of the SSO as seen by the satellite and cross-matches this against the images in the 3 archives. So we have targeted and we also have serendipitous results. Let me show you an example. If I type in Psyche, we are given the option to search for the asteroid, and we're told that we have some Herschel observations. So when I click on this, we're zoomed out on the whole sky, and what we see here is the orbit of Psyche as seen by Herschel during its entire lifetime. And if we center on the observations, we can see them here, the footprints in the sky. We see that we've got 2 Pax and 2 Spire observations. Let me change the background hips now to Pax. And if we zoom in here, so we can see falling perfectly on the orbit. In the background hips for Pax, we see the asteroid appearing twice because the hips were made up from the 2 images. We also see this in in the postcards as well, coming from Herschel. And these were not targeted observations, so the target for these observations were L1551, which is a dark cloud nebula. So these are serendipitous observations. Now, a NASA mission is going to Psyche in the 2020s, so these serendipitous observations by Herschel could help to refine some of the physical properties of the asteroid. And there will be a publication out soon by the team describing the SSO algorithm and the analysis of these Herschel images on this asteroid. So finally, let me take just a few minutes to show you the pyESASky Jupyter widget and some typical things that you can do in a Jupyter notebook. So this is a notebook open in Jupyter Lab. We have pyESASky open here, and you can find this notebook in the GitHub of ESASky under the samples directory. This notebook shows examples of what you can typically do with pyESASky. In particular, you can download and inspect data from ESASky. You can cross-match catalogues available through ESASky. You can upload your own data, and you can interact with ESASky functionalities. So I won't show you everything now. I will provide links to this notebook at the end of the presentation. And please also see our ESASky e-poster that also has details. So if I jump down here where you can actually load up your own data. So we do a cross-matching of catalogues and you can load up your own data in ESASky. So this is sending a cross-match table to ESASky. We can also send catalogues from Vizier, so loading up the AstroQuery Vizier module. And you can search for any catalogue and then load it back into ESASky. So if you're interested in learning more about this, as I said, please see our e-poster and please check out the links at the end of this presentation. Plus, if you want to find out more information, you can go to the documentation within ESASky, so just click here and you, for example, click on the video tutorials, and here we have many videos. We have a video of pyESASky as well, and we have links over here. For example, here's the link to the pyESASky widget and information on how to install pyESASky. So the creation of ESASky isn't possible without collaboration, e.g. with other data centres. For example, with CDS, we are using their Aladdin Light tool to visualise the sky, and we're also using their astronomical name resolver Simbad and Sesame, and we're using Simbad to expose the sources with associated publications. We have worked with the AstroPy community, in particular AstroQuery, to create an AstroQuery ESASky module, and of course we've created the Jupyter widget pyESASky. This allows users to do more sophisticated studies of the data. And let me emphasise that all of the interoperability you see in ESASky is thanks to the International Virtual Observatory Alliance protocols, of which we are using many. And this is thanks to the international collaboration between astronomical data centres. So please try ESASky yourselves. These are all the people and institutes that have been involved with the tool so far, and we welcome contributions from anyone who's interested, so please contact us. This slide gives you some useful links, and finally, if you have any feedback, contact us via User Echo, and please also see the ESASky and pyESASky e-poster. Many thanks for your time.